Multiplying polynomials. Our objective is to multiply polynomials, as well as use binomial expansion to expand binomial expressions that are raised to positive integer powers. Who uses this? Business managers can multiply polynomials when modeling total manufacturing costs. So to do this, use the distributive property and the properties of exponents. So let's start by multiplying a monomial and a polynomial. We're going to find each product. So we're going to use our distributive property and our properties of exponents. So we're going to distribute our 3x squared across, and we're going to use our properties of exponents to determine what our exponents should each be. So we have 3x squared times x to the third, so we're going to have 3x to the fifth. Since when you multiply bases, or common bases, you add the exponents. And then we have plus 3x squared times 4, which will leave you with 12x squared. Now let's look at b. We have ab times a to the third plus 3ab squared minus b cubed. So ab times a to the third will be a to the fourth times b. And then we have ab times 3ab squared. So that's going to be plus 3a squared b to the third. And then our final one is going to be a b to the fourth. And it's a minus, so keep it minus. Well, that's a monomial and a polynomial. Well, what if we have a binomial and a trinomial, or two trinomials? When you're doing this, simply take each term from your binomial or trinomial on the left and multiply it to each term of a binomial or trinomial on the right. So we're going to distribute our x to our x squared, our 4x, and our minus 3. Then we're going to distribute our 2 to our x squared, our 4x, and our negative 3. So let's practice. We have x minus 2, that quantity, times the quantity 1 plus 3x minus x squared. So we're going to distribute our x across, leaving us with x plus 3x squared minus x to the third. And now we need to distribute the negative 2. So we have minus 2 minus 6x, and then plus 2x squared. We have one more step. We have to combine like terms, and then it might be best to keep things in standard form. So we have only one of our x's cubed, so we have negative x cubed. So that one's all set. And now we have 3x squared and 2x squared, leaving us with a positive 5x squared. And then we have an x and a negative 6x, which provide us with minus 5x. And we only have one constant, so minus 2. Take a moment and pause the video and try B. You're going to follow the same pattern that we did in A, only it's a trinomial times a trinomial. So try distributing across for each piece. Okay, so we have our x to the fourth from distributing x squared to x squared, and then we have minus x to the third plus x squared. That's your first term. Then your second term after it gets distributed is 3x to the third minus 3x squared plus 5x. And then when we distribute our third term all the way across, we have minus 5x squared plus 5x minus 5. And now we can combine like terms. So we're left with x to the fourth plus 2x to the third minus 7x squared plus 8x minus 5. If you're having trouble, you can try making this into a table. For example, take one of your trinomials and place it on the top, and the other trinomial and place it on the bottom. Make sure you keep the sign that goes with each number. So it's a positive 3x and a minus 5, and a negative x or minus x and a positive 1. And then you can multiply each. So you'll have your x squared times your x squared, then your x squared times your 3x, and then your x squared times your negative 5. And when you have your table, you can then simply put them all in a string. So you take whatever the sign is that's in front, and you can combine like terms, and either way you still end up with the same end result. So whichever way is easier, you may use. Now let's look at expanding a power of a binomial. So we want to find the product. No, it is not x to the third plus y to the third. It's the whole quantity x plus y to the third. So you can rewrite this as x plus y times x plus y times x plus y. And then simply do two of them at a time. So we're just going to ignore this third one for right now. But it is going to come back. It does not just go away. Alright, so we have our x times our x, leaving us with x squared. And then we have plus xy. And now we distribute the next. So we have y, so we have plus xy, and then plus y squared. If we combine like terms, we have x squared, and then we have 2xy, so 2xy, plus y squared. And that trinomial is then going to be distributed across this binomial that we didn't forget about, we just kind of ignored it for a little bit. So our x plus y. Alright, so we distribute when we have our x squared times our x, leaving us with x to the third plus x squared y. And now we distribute our 2xy. So we have plus 2x squared y plus 2xy squared. And our last piece would be plus xy squared plus y to the third. And last but not least, combine like terms. So we're left with x to the third plus x squared y, and then we have a 2x squared y, so we've got 3x squared y, and now we have a 3xy squared, and our last one would be plus y to the third. There is an easier way to do this, and that's by following Pascal's triangle. So let's take a look. So when you're looking at a binomial expansion, you can do it the longhand way. If you like, just like we did here, it will always work. But it follows a pattern, and that pattern is Pascal's triangle, and it's your coefficients. So if you look at a plus b, so that quantity to the first power, the coefficients of a and b are 1 and 1, so that's your second row of Pascal's triangle. Well, let's jump down to a plus b to the third. So we have a plus b to the third, meaning that you're going to look at the fourth row here of Pascal's triangle. So we have 1, 3, 3, and 1. So our coefficients are 1, 3, 3, and 1. Alright, so since Pascal's triangle covers the coefficients, let's look at our exponents and see if we can notice a pattern. So if we're squared on both sides, our middle is just going to be to the first. And then if we're looking at our cubed, if we're cubed on either end, our next pieces are going to be squared. But notice how your first term to the left on the inside is going to be the a is squared, and then the first term coming in from the right, the second term, so the b is going to be squared. All right, well, let's look at the pattern of the exponents for a power of 4. So our extremes are going to be a to the fourth and b to the fourth, but now we need to figure out the rest of the middle. So we have 4a to the third, so your first term is to the third and b is by itself. And if we come in from the right, we have 4a is to the first, but b is to the third. And then go in one further, we have 6a squared b squared. So going in on both sides, notice it goes 4, 3, 2, 4, 3, 2. And then you just have to go, okay, so if it's going from the left, the first one is going to be the one that's getting that power. From the right, that second one's going to be the one getting the power until you hit the middle. And your coefficients are determined by Pascal's triangle. So let's try it out. So we'll do the first one together, and then you guys will try the second one here, where it's to the third power. So we're looking at a power of 4, so we need the power of 4 for Pascal's triangle, which would be 1, 4, 6, 4, 1. So those are going to be our coefficients. So our coefficients are going to be 1, 4, 6, 4, 1. And then we'll deal with our exponents as we go. So our first term is going to be 1 y to the fourth. And if you think about it, you can go with, oh, well, our second term is technically to the 0 power, if that helps. And I'll put that in a brace. So plus, and then we have a 4 for our coefficient, so we have 4y to the third, because we're going down here, 4, 3, and then it's going to be negative 3 to the first, because it's going to exist this time, and then plus, our next coefficient is 6, so we have 6y to the second, and we'll have negative 3 to the second, just like in that very center. If we go back here, our very center is 6, our first term to the second, and our second term to the second. And now we're going to the other side of our triangle. So we have our coefficient of 4, and it's going to be y to the first, and then negative 3 to the third, and then plus our 1y to the 0, if that 0 helps, and then we have negative 3 to the fourth. A lot of times I won't even write in this piece here, because I find it sometimes easier to notice the pattern by just writing in our 4, or our extremes for our exponents. So now we can simply simplify each one of our set of braces here, or brackets here. So we have y to the fourth minus, and that's going to be 12y to the third, and then we have plus our 54y squared, and we've got minus 108y, and then plus 81. So each one matches up. We've just simply simplified each aspect. Take a moment and pause the video and try B. When you return to the video, the answer will be revealed below. And there you have it. If you're struggling, you can always revert back to doing it the longhand way if you can't do the pattern. However, this ends our video on multiplying polynomials.